Hello everyone, welcome to Joker's Carnival. In today's video, we are going to dive into an interesting coding problem called the cheapest flights within K-stops. This problem deals with finding the most cost-effective way to travel between cities given a set of flights with associated costs. Let's explore the problem statement and understand the details together. Imagine there are n cities connected by various flights, each with a specific cost. We are given an array called flights, where flight of index I, which contains from the to and the price of that indices. This indicates that from I to city 2i, the cost of that flight will be price I. Additionally, we have three integers, the source, the destination, and the k. K meaning the maximum number of stops allowed between the flights. Our task is to determine the cheapest price to travel from source to destination with at most k stops. If it's not possible to reach the destination within the given constraints, we should just return -1. Now let's understand the problem better with a couple of examples. As you can see from the graph, we have n, which is the number of cities given, equal to 4. The flights given as from city 0 to city 1 the cost is 100, from city 1 to city 2 the cost is 100, from city 2 to city 0 the cost is 100, from city 1 to city 3 the cost is 600, from city 2 to city 3 the cost is 200. And we are also given the source 0 and destination 3, and the maximum number of allowed stop is k is equal to 1. The optimal path with the most one stop from city 0 to city 3 is marked in red, as you can see in the graph. Has a cost of 100 plus 600, which equal to 700 in total. Note that the path through cities 0, 1, 2 and 3 is cheaper but is invalid because it uses 2 stops, which goes against the constraints given. In example 2, as you can see, the number of cities is 3. The flights are from 0 to city 1 the cost is 100, from city 1 to city 2 the cost is 100, from city 0 to city 2 the cost is 500. The source is 0 and the destination is 2, and k is given as 1. The optimal path with at most one stop from city 0 to 2 is marked in red and has a cost of 100 plus 100, which equals to 200. The problem comes with a set of constraints we need to consider. N should be between 1 and 100 inclusive. The flight length should be between 0 to n into n-1 by 2. The flight's I length should be 3. From I and to I should be between 0 and n. From I should not equal to I. Price of I should be between 1 to 104. There will not be any multiple flights between two cities. Source, destination and k would be between 0 and n. Source will not equal destination. Now let's walk through the Python solution that tackles this problem using the Dijkstra's algorithm. We employed Dijkstra's algorithm, a popular and efficient algorithm for finding the shortest path in a graph. This part of the code defines a class solution with a method find cheapest price. The method takes 5 parameters: n, the number of nodes; flights, a list of directed edges represented by u, v and w, where u is the source, v is the destination and w is the weight. Source is the source node, destination is the destination node, and k is the maximum number of stops allowed. In this section we can see we have taken a default dict, which is used to create an adjacency list representation of the graph. For each edge u, v and w in the flights, it is added to graph dictionary. The keys are source nodes u, and the values are lists of tuples representing the destination node v and the edge weight w. Here we have taken a priority queue pq, which is initialized with a tuple representing the cost, the current node and the stops. The starting point is the source node with a cost 0 and 0 stops. Here we have taken a dictionary memo, which is created to memorize the minimum cost for each pair of node to stops. This helps avoid redundant calculations and improves the efficiency. The main loop starts here, continuing until the priority queue is empty. In each iteration, the tuple with the minimum cost is popped from the priority queue. If the current node is the destination node, the cost is returned as the goal is reached. Otherwise, if the number of stops is less than or equal to the allowed maximum stops k, the script iterates over the neighbors of the current node. It calculates the new cost and updates the memo dictionary. If the new cost is smaller, the updated information is then added to the priority queue. If the loop completes without reaching the destination node, it means no valid path was found within the given constraints, and thus -1 is returned. Now let us run the test cases to see how the solution is performing. As you can see, we have run the test cases and all the general test cases have passed. Now let us submit. We have submitted, and as you can see, the solution works for all the cases provided, and it is also very optimized solution, not the most optimized, but it is optimized enough. In conclusion, we now have an effective solution to the problem of finding the cheapest price to reach a destination within a specified number of stops. It's a great example of leveraging data structure and algorithms to tackle real-world graph-related challenges. If you found this video helpful, don't forget to like, share and subscribe for more contents. Thank you for watching. I will see you in my next video.